Somebody said to me, gee, I wish you could do a reality show. And I thought to myself, actually, we could do a reality show. And the reality show would be around watching prototyping come together for the people who are working on these amazing inventions across the University of Minnesota, as bringing their ideas one step closer to market reality. And my impression was, gee, Protolabs could help with this. And that laid the seeds for this wonderful partnership. Protolabs has been especially helpful where it's not just that supporting us financially and with the in-kind benefits, but what's really important is the connection with your design engineers and with the whole process that Protolabs uses to initially review designs such that they could be actually produced, which for many students is a new way of thinking. So we're adding to their education to really be able to say, what does design for manufacturing mean? What does it actually take to make something that could be actually produced?
I really like that you could upload your parts really quickly to the service, and then you could get your quote back and see where there are problems. And then also it was helpful working with people at Protolabs and how we can make our design more efficient.
We got prototypes and stuff almost the week after we sent them in, so that was really nice. And then also it was just really easy to see how it would work and what would come out of it, and just the ease of putting in parts, STL files, and then getting it back in a week is just nuts.
Our project is dealing with ovarian cyst removal. So when you get an ovarian cyst, your body actually, it's one of the few muscles in your body that will expand exponentially, so they can get gigantic. The issue with this is that they don't know whether or not it's cancerous. So what they do is they make an incision from your pubic bone all the way up to your chest plate, and then they remove the cyst whole, because if they were to aspirate and leak that cystic fluid into the body, you could leak cancerous fluid into the body. So our device design is to allow them to aspirate within a contained system. So our device suctions to a cyst, and then within this opening is where they can perform the procedure to aspirate it, and then you minimize the incision down to 5 centimeters. I did a first initial meeting of what's this process look like, how can we be most successful with this, and they were so kind and very helpful. They answered all of my weird questions. And then after that, anytime I made design changes, I met with them to go over and talk about it and to make sure that they had an overmold made so that the sectioning was correct and that we got what we wanted out of the final print.
So our walk canes are meant to fill a void in rehabilitation between someone using a walker and a single point cane. Right now, there's often not a lot of support in that in-between stage. So it makes it very hard for someone to transition out of using something more assistive like a walker. Protolabs let us get running right away. So we had a bunch of prototypes we wanted to 3D print, and we really needed that engineering grade material that allowed us to put our full amount of weight on these, test it in a clinical setting, and so on. So from that first point, we were able to print more, and then test with our users, and then iterate, and then keep continuing to improve our product.
Several of the projects that were in the MVP Challenge are also in courses. And one of the courses that's quite heavily represented here is our Biomedical Engineering Senior Design course. And a couple of those projects worked with Protolabs, and they got a totally different kind of angle on their projects versus what they learned from their professor, who looks at things more from an academic perspective and a how would it work in the lab perspective, as opposed to how would I actually make this and make it at scale.